Hello everyone, and thanks to join us in the news technical talk at Deloitte Cyber Icon about web application security. That will be done with Radware. I am Juan Senovilla, product manager of the Deloitte infrastructure team for all our clients in EMEA. And let me start with a brief overview of web applications. The websites and web applications have become more and more dominant, adapting to the rising popularity of the internet. This new era has brought change to the way that we communicate, link, shop, and create. As a result, we are now living in a world where both information as well as user information can be lost or stolen due to security breaches or caused by simple errors in programming or user errors. Every second counts when it comes to security online clients assets. Learning how important it is for all business using web applications to fully understand web application security is one of these goals. But why are web applications so important? Many of us use this application on a daily basis to make online shopping purchases, take our packet transactions, make an online doctor appointment, or check the price of airline tickets. These are examples of companies that daily put the security on their applications and their business in the hands of Radware as a cybersecurity manufacturer and Deloitte as a professional service provider. But back to the topic, web application security refers to a variety of approaches, technologies, methods for protecting web servers, web applications, and web services, such APIs from attacks by internet-based threats. With so many vulnerabilities being found each day, it becomes so difficult for users and companies like Deloitte and Radware to keep up with how vulnerable the website can be if the protection is implemented correctly. These cyber attacks exploit vulnerabilities in your web applications and conduct that disrupt business continuity or hurt the bottom line in the business. Besides, cyber attacks threaten the data of your customers and can cause irreparable damage. Common web application risks in cloud attacks like DDoS, which stands for Distributed Denial of Services, SQL, cross-site scripting, etc. But to help us to defend our clients, here with me is Alessandro Tagliavino, is a Radware Cloud Sales Technical Specialist. Radware is by far one of the largest companies in cybersecurity and is totally focused on DDoS, web applications, and cloud security, among others. Thank you, Alessandro, for joining us at the Deloitte Cyber Icon event. It's a great pleasure.
Thank you, Juan.
To stay here with you here today.
Okay.
Alessandro is going to talk about one of the hottest topics in these days in web application protection, and I leave you with his presentation. And thanks everyone for joining us.
Okay. So Juan, thank you so much, and thanks for Deloitte to hosting us in this event. Today, I'm going to share with you some slides about Radware technology, and I will be glad to go deep in some feature about our web application and API protection suite. But before we start, I would like to show you some consideration about the scenario we are facing every day when we speak about application security. The first things to consider is that bots are taking over the internet. Basically, in the last years, the percentage of client traffic generated by not human-controlled device is increasing because of mobile devices, cloud infrastructures, IoT. And basically, the half of internet traffic is estimated to be generated by automatic process, okay? So the half of this amount of traffic is a huge amount of traffic, can be considered bad traffic because it is performed by automatic systems that are not running useful tasks like search engine, pricing services, and so on. So in this flood of traffic, most of the customers, most of the operators in the market are not really able to distinguish what is good and what is bad. And the challenge is to find an efficient way to filter out both traffic that in some cases is not carrying useful transaction, in the worst cases is performing attacks against infrastructure. For instance, if you look at some analytics from a website, e-commerce website, you will see that you can find the typical signal of bot traffic. You will find huge hits per page, huge number of hits per page. You will find increasing some parameters like bounce rate. So when a user is connecting to the landing page of the services, but is not doing anything else and leave the page soon, you will find a lot of fake conversion. So fake sign-in, fake form sent with no significant data. And you will see that the session lifespan is too short or is too long if compared with traditional or with regular transaction on your web application. And usually you can find strange geo activities that can be related to region where traffic usually is not coming. These are always signals that you can find in every web e-commerce application, and it's a clear indication about the presence of bot over the network. For the API system, the situation is exactly the same. Today, API represent the main technological engine to develop advanced products and services in ICT market. Okay. But basically, the API are not standardized, so it's not really easy to understand what is an attack, what is not, using traditional technologies. And in some cases, it could be possible using even heuristic technology to make some mistakes. And there are some infrastructure like software as a service, e-commerce or gaming that have zero tolerance to this kind of problem. Basically, bots traffic generated over the internet can target all the channel of a service infrastructure, the website, the mobile application, and the API infrastructures. Bot attacks can be divided in some families according to the OWASP classification. OWASP is in charge of listing web application vulnerabilities, but OWASP has released a classification for bot attack as well. The first family is the account takeover, is a family of threats that are related to the usage of credential in a good way, in a bad way. So credential stuffing, credential cracking, brute force attack, or everything that you can do against a web server or web services using a regular credential. The second family is the web scraping. In this kind of threats, the activity of bot is related to collecting data from a website. This data can be price, can be intellectual properties, and everything that can be useful for to the competitors, for instance. Then we have denial of inventory. Inventory. In this case, this kind of attacks is targeting basically e-commerce website, because bots trying to book all items they can in order to stop the regular transaction for the real user that want to close the transaction. Then we have the pure application DDoS, when the bots are able to stop services or microservices that are running the application and can impact the availability of the entire system. Then we have payment data abuse, everything that is related to the payment process, so the stealing of credit card number or changing prices, everything you can imagine that is dealing with the last stage of the transaction, normally the payment. And the last one, that's very important, is the distortion of marketing analytics. You know that if you want to manage, if you want to operate efficiently a web server, a web application, e-commerce, e-government, everything you need, you should check periodically the analytics, because analytics is leading you to the right development according to the user needs, according to the user requirements. Bot traffic can create a big distortion in this data, giving to you a bad depiction about the website. So it's not easy to understand how you can change, you can improve the performance of your system over time, because the data you can get are not accurate. So basically, bot traffic does create a lot of risk for any organization that is operating business online. In particular, the most important classes are data theft, loss of reputation, financial loss, and availability issues. But regardless of these categories, the most important thing is that the investment that you have to put in place after an attack campaign, it's always more and more expensive than the solution that can protect to you since the beginning. That's the reason why bot management solution is not an option for all the organizations that are running online business. Having said that, I want to introduce you to Radware Bot Manager. and tell you something about some unique feature Radware is deploying in order to deliver the best solution in the market. Basically, you know that bots can be divided in different generations, starting from the first one to the third. And according to the generation, we have a different level of complexity. So the first bot can do something very easy. The last one can simulate completely human experience and try to evade a lot of traditional protection that you can put in place to protect the infrastructure. For every kind of generation, you should deploy the right countermeasure that is able to stop completely the attacks against the infrastructure. The good news is that Radware can provide a wide spectrum of protection that is ready to protect any kind of application infrastructures against bot traffic. In particular, the solution can be considered complete because you can deploy a solution able to stop all the families of attacks we saw before. We are using to collect data across different intelligence threat sources all around the world. And we have some particular feature about machine learning and mitigation system that make our solution unique. In particular, today I want to speak with you about two features. Here you will find a list of some detection and mitigation options that our solution can provide. Most of them are available are quite common in every solution in the market. But in particular, the first one, enhanced learning machine learning capabilities and the crypto challenge is something that Radware deployed by itself, and is something unique for this kind of technology. So let's see what this feature can do for the application infrastructure. In the traditional approach to the machine learning, most of the solutions that you can find use the model of supervised machine learning. What does it mean? Basically, in this kind of model, you have a set of data, and this data is correlated to the output. So we know in advance if the data we have can be considered something that is an attack. In this case, in our data space can be something like a vector that contains information about a communication between a client and server. So think about a vector that contains IP address, user agent, HTTP headers, information sent and received, all the parameters that can describe correctly a communication between a client and server. In this case, using machine learning technology, what we can do is to train with very well-known data called labeled data, a classifier to check if any previously unseen input can generate an attack. This is basically what a lot of technology are doing in terms of machine learning. This technology is very easy to deploy because it's affordable in terms of computational cost. It's based only on labeled data, but labeled data can be scarce or can be expensive. In particular, this technology has a problem. It's static technology because it's based only on what we saw in the past. So any emergency malicious behavior in the application can be undetected. Okay, that's the big risk. To overcome this challenge, Radware decided to use a complementary approach called unsupervised machine learning. In this case, the model is a little bit different because we are going to leverage what we called unlabeled data. So we have a lot of data, huge database of data, where there's no information about the relation between the data and the occurrence of an attack. So the question is, how can I get information from this data? Basically, to do that, I have to make some assumption about the way I create the data, about the way I described the connection between client and server. And that's the secret sauce, basically, of the technology. So we are able to classify correctly the data to meet the assumption about all the inputs. When I speak about assumption, I'm referring to the assumption related to the unsupervised machine learning model. So we are able to, we are quite sure that the data we have, the unlabeled data, can be reordered, can be clustered in order to be bound with a high prediction rate to an attack that is describing an output. In this case, we have to pay something because this kind of task is very high consuming task and it requires a lot of computational resource. But on the other side, we can access a huge database of unlabeled data. Why that's important? I will try to give you a brief example about communication between client and server. So let's think about the data that describe correctly what happens between a client and server during a communication. There is an exchange of data at network layer, there is an exchange of data at application layer, and everything can be used in order to classify this communication. For instance, my learning system can tell me that if I'm gonna find some values for user agent or for lifespan of connection or for information exchange, I can classify this connection as malicious and I can decide to block it. And this is something that can be very useful. But what happens if, for instance, I'm not receiving all the parameters I'm expecting for? In this case, that's the place where the semi-supervised learning come in, because I can correlate parameters that are in the unlabeled data to the labeled data. And I can feed my classifier from the supervised machine learning with data that are cheap and high available basically everywhere. So this approach is possible because we are using patented semi-supervised machine learning. So we have our own algorithms that are able to overcome the challenges of performance degradation and assumption on the clusterization of the data. And this is leading Radware to create an approach that can deliver the highest precision in the market in terms of detection based on machine learning system. Having said that, I will pass to the second part of the presentation, and I'm going to speak about crypto challenge. Crypto challenge is a technique to mitigate attacks. So it's something that can be used to block or to limit access to the bad user, to the bad guys to my system. What we're going to do with crypto challenge? Basically, crypto challenge is meant to improve the user experience, asking to the client to do something. What? Basically, they have to prove to be a good client so they can be connected to the application. The way we ask this is to solve a parametric mathematical problem with no human interaction, okay? So this could be useful for API, could be useful for mobile user or traditional web user. The most important thing is that the user is not involved in this kind of process. To do that, Radware thought about a challenge that shall satisfy stronger requirements. First of all, as I told you, this technique should not be interactive. No human touch shall be required in order to complete the challenge. This could be publicly auditable. Everyone that knows the algorithm used should be able to check if the client did what the server asked for. This should be probabilistic outbounded cost computational. What does it mean? Basically, we have to send to a client a request to do something. The workload, the work factor we have to use, it's up to us, it's up to the server. So we can challenge more and more all the client we believe are malicious. Then it should be trapdoor free. So no one that has any particular or secret information should fix this challenge in a very easy way, or maybe it's not possible from theoretical point of view. And at the end, it should be harder to be solved by chances. If you think about the CAPTCHA, maybe you will find that this is one of the best I've ever found over the internet. Basically, muffin or dogs are very, very similar, but even this CAPTCHA that works quite well is not satisfying all the requirements we need. In particular, to address this kind of requirement, we have to use something more complex. And to do that, we decide to use a set of functions. Sorry for the notation, could be very complex, but at the end, the message I want to deliver is very easy. So we have a set of instructions that server is going to send to the client in order to do something. When you say to do something, what I mean? I mean, find a number with particular feature. this number should be a number with 160 digits in this case, and I have to be sure that the first 120 are 0, okay? To do that, I have to be sure that this challenge is performed by client and server. And to do that, I can use the parameter S, that is parameter that I'm going to use to identify the server. The W parameter is the workload. So is how much is work factor, sorry, is how much work I have to ask to the client. The client will use a value, a root value I calculate in order to start to search for this number, to be sure that client cannot pre-calculate anything. So I want to be sure that client is exactly doing what I'm expecting for. Client is giving to me back a parameter called T, it's a token. And once I have the token, I'm using the public hash function to check if client really did what I asked for, okay? So this can be very complex because mathematical notation can be complex, but at the end, the idea is very simple. Because of mathematical theorem, we can assume that the best way to search this number from client perspective is to perform a brute force. So the client should perform a brute force searching for a given number in a huge set of numbers. This is not a problem because this kind of brute force attempt can be performed in microseconds. On the other side, we can control the W factor in order to say how it's difficult to find this number. And according to this, we can wait and we can module the delay of the user while the client is performing these challenges. We can choose to block complete resource, or we can choose to accept sources that are able to solve the challenge. With timestamp, we can guarantee the security of this mechanism. But the most important thing is that this mechanism is completely automatic, is based on injection of JavaScript from server to the client, and is fully transparent for the users. So in this case, you can have the huge protection because you can do something more than traditional CAPTCHA. You can do something more robust than any other kind of protection that now are available in the market. Maybe some of you has recognized this because this kind of approach is called proof of work. It's the base of the mining of the electronic cache. It has been already used in some anti-spam solution, and that's basically is the Radware implementation of Hashcash protocol. So it's not rocket science, but the secret sauce is the way we are able to bring this protocol in the real world, in our technology, to automate all the stages for the customer. The nice story is that all this technology is already available in all deployment way we have for the services. So we can deploy our bot manager as reverse proxy, physical, virtual, in the out-of-path mode. So your front-end application can speak through API with our services, or you can leverage our cloud services that is based on a huge network of data centers, at least 20 data centers spread all around the world. We are working actively with the biggest cloud providers, and we can protect against all attacks the infrastructure, against all bot generation, and we can protect all the channel of the web server of the application infrastructure, minimizing the false positive. I have finished. Thank you so much. And if you have any additional question, please let me know. I will be glad to reply. Thank you.